All right, everybody's got some paper out for some notes. You don't have to copy this drawing down. I just want to remind you of what we're talking about when we say that we are dealing with the real number system in general. Okay? Because lesson 3.2 is on the complex number system. So this was good old real number system. Whenever we talk about our numbers and so forth, we're saying, hey, what can you do in the real number system? And there's two things that we can't do. Does anybody remember what those two things are? We can never, ever, ever divide by what number? Anybody remember? Can't divide by 0, okay? And in the real number system, we can't take the square root of a negative number, okay? Those are the two things that we can't do in the real number system. So back when you were a young child, the very first thing you learned how to do was to count. And you counted with 1, 2, 3, etc. Those are your natural numbers. So when we talk about natural numbers, we're talking about our counting numbers. And we get a little bit bigger and we can count to bigger numbers. And then by the time you're in kindergarten, they want you to be able to count to 100. You remember those days when you had a test on that? Okay. Then you learned about the number 0. And that's what made our added 2 to make our whole numbers. That number 0 was when there were no more fruit snacks. There are 0 fruit snacks in the pantry. You can't have any. I'm sorry, I have to go to the grocery store. Okay, remember being disappointed with the number 0, most likely. And then you learned a little bit more about the integers. And the integers involve numbers like -8. No, you can't go outside right now. It's -8 degrees out there. It is too cold for you to go play with your dog or what have you. Okay? So you learned about negative numbers, owing things, and so forth. Those are the integers. Then about 3rd or 4th grade, you learned about something called fractions. And you learned how to divide, and things didn't come out nicely. So you ended up with decimals. Fractions and decimals are part of our rational number system. So far, so good? Okay, then we learned that there are some numbers that can't be just written as a nice little fraction with the numerator over the denominator, or don't have a repeating decimal. They go on and on and on, and they never terminate, they never repeat. Can anyone give me an example of one of those numbers? Pi, yeah. In fact, Mr. Moore has a picture of pi up here, right? And it has numbers that go on and on and on forever. So those are your irrational numbers. And we also have one called e that we're going to be talking about as well. And any number that doesn't terminate or repeat, doesn't have a pattern to it. Okay? So that was your real number system, and that was all you knew until today. Okay? We're going to introduce a new number to you, and it's going to be part of what's called the complex number system. Okay? Never seen it before. All right, so the complex number system is similar. It has all that real number system that we just talked about with our counting numbers and our 0 and our negative numbers and our rational numbers and our irrational numbers like pi and e. But now we're going to talk about some imaginary numbers. Okay, so Sesame Street time. You're back into the imaginary world. You have to use your imagination here. Okay, the imaginary number that we are going to introduce is the square root of a -1. Okay, so if we had x squared equals -1, and we wanted to take the square root of that to solve it, we now are introducing an imaginary number that will take the place of the square root of a -1. That imaginary number is going to be called I. I for imaginary. Okay? Nothing too bad there, right? So write that down. You've got a new number. It's called I, and it stands for the square root of a negative 1. Okay. And we can actually um, do more than just talking about plain old I. We can have other kinds of imaginary numbers like 4I, 4 of those square roots of a negative 1. Or we can have two parts to that. One of them is the real part, and the other is the imaginary part. And altogether, it makes a complex number. So 2 plus 3I is a real number with an imaginary number. We always write the imaginary part second to be in standard form. And negative 3 plus 1I is also a complex number. Okay. So now we can do things like finding the square root of these types of numbers. So write down letter A. We want to find the square root of a negative 81. So the square root of a negative 81. Well, I'm going to rewrite this because I can think of this square root as being one big parenthesis, and as long as I keep things inside of there, I'm in good shape. So I have really negative 1 times an 81. Isn't that the same as negative 81? Okay. You all know how to take the square root of 81, right? And we can separate those as two separate factors. What is the square root of 81? 9. And what did we just decide, or what did we just define the square root of negative 1 as? I. So you can split it up and write it out that way, or you can recognize that this is just our friend 9 with an I behind it. Everybody okay with that? Haven't confused anybody. Okay. So the next one, letter B, is a little tougher, but nothing that you haven't handled in the last few days. When we ask you to take the square root of 56, what would you typically do? Find any perfect squares in there and take them out of that square root, right? Well, 56, first of all, I'm going to go ahead and write my square root of negative 1 so I don't forget about it. But 56 is 8 times 7, right? Does 7 have a perfect square in it? Nope. Does 8 have a perfect square? Yes. What's its perfect square? 4. That's 4 times 2, isn't it? So the 4 comes out. When it comes out of the radical, what does it become? The square root of 4 is 2. This 2 isn't a perfect square. The 7 isn't a perfect square, so they stay inside as a what? 14. And then what do we have to do about this negative 1? Make it an I. So that will be 2I times the square root of 14. Okay. Usually it goes at the end. When we have a radical, we like to put the radical at the end. So if you wrote it as 2 square roots of 14i, that's perfectly fine. What happens is sometimes students want to keep going with that radical bar, and then they get the I back underneath the radical. These are equivalent. There's nothing wrong with either one, but we would prefer to see this because we don't want to extend that bar across the top. The I came out. Yes, Sydney. The 4 became a perfect square. So when we had a 4 times 2 times 7, we're just writing products of the factors here. The square root of 4 is a 2. Okay? Right. Most people typically think of 8 times 7 as 56. Okay? So everybody's okay with those two examples. Okay? Here's our next one. We have a negative 7 times the square root of a negative 12. Okay? So what's going to happen? Is there a perfect square inside of that square root? Dylan's nodding his head. What's that perfect square, Dylan? Good. We can take a 4 out. What's going to be left inside? Good. So we found our perfect square. 4 times 3. So that negative 7 is already out there, right? We're going to have a negative 7. When that 4 comes out, the square root of 4 is what? 2. So we're going to put the 2 outside. That negative 1 here becomes square root of negative 1 is I. And what didn't get to come outside? 3. So we leave the 3 inside the radical. Okay? We're not done because we have to do a multiplication problem here first. So what is negative 7 times 2? Negative 14. So we'll have a negative 14 times I times the square root of 3, or if you prefer to write it as negative 14 square roots of 3 times I, that's fine too. Right. They put it in front of the radical. Yeah. They're equivalent. There's nothing wrong with it. It makes you feel more comfortable, by all means. Okay? So far, so good. Nothing earth-shattering here. Okay? The great thing is there's not going to be anything earth-shattering here. We're going to, a lot of the same things that we've been doing, we'll continue to do the same things. So first of all, complex number in standard form. Okay? A complex number is written in standard form when it is of the form a plus bi, which I kind of mentioned a moment ago. 2 plus 3i. We put the real part first and the imaginary part second. Okay? Yep. This is just something new and foreign to you. But it's not really that difficult. It's just something we haven't encountered before. All the rules of algebra are going to apply to it. Drake, do we need to get you up and stretching? Sleepy people today. Yep. Okay, everybody's finished writing? No? Give you a couple more seconds. All right, here we go. So when you're adding or subtracting complex numbers, you add or subtract the real parts together, and then you add or subtract the imaginary parts. Real with real, imaginary with imaginary. So you're going to be combining like terms. Your real parts are your like terms, your imaginary parts are your like terms. And we don't combine, we don't try to do anything to make the real and the imaginary smoosh together. We're just going to have two parts in many cases. Okay. All right, so this first example is going to ask us to add 2 plus 9i with negative 11 minus I. So be very, very careful here. It looks like we have parentheses, and we immediately want to FOIL. But the only reason they put the parentheses there is to remind you that this is one complex number, and this is another complex number. Okay, so don't think FOIL. Don't think distribute. Don't think FOIL boxes. Think I'm adding. And if it helps you to remove the parentheses, please do. It's just this is the way the book presents it. Okay? Later on in pre-calc and algebra 3 textbooks, they don't put them in parentheses like that necessarily. Okay? So we ask ourselves, what are our real parts? Which two numbers in letter A are the real parts? Someone say it louder. 2 and 11, thank you. So 2 and 11 are our real parts. So we're taking 2 plus 11. I'll write that intermediate step, but you don't have to write that down unless you want to. Okay? And then which parts are our imaginary parts? Yep, that negative I and the 9I. So when we combine those, 2 plus 11 is how much? 13. We'll have 13 for our real part, and a positive 9i and a negative I is a total of 8i. That's our complex number. Nothing earth-shattering, right? We can do this stuff. Okay? Now here's where that parentheses is nice to have, because it's reminding us that we are subtracting both the 8 and the positive 4i. So you can think of this as a negative 1, and you can think of distributing that negative 1 to both. So what are our real parts? 13 and negative 8. I would agree with that. And the common mistake that people are going to make is to not distribute this negative 1 to that 4i. Okay, we're subtracting both parts, not just the real part. So what are our imaginary parts? The 4i and the 4i. So we have to take 4i and we have to subtract 4i from it. Does everybody see why it's subtracting 4i? Okay. So a positive 13 and a negative 8 gets us 5. That's our real part. Positive 4i and a negative 4i gets us 0i, and 0 times anything is 0. Do we have to write it down? No, it just disappears. So we took a complex number, added a complex number, and only got a real number back. Special case. Easy enough, right? Okay, next example. We have 16. We're subtracting 13 plus 6i, and we're adding 8i. Vivian, which ones are my real parts? Good, 16 and 13. Okay, don't forget, this is a -1 that's going to be distributed to both of these guys. Okay, so 16 minus 13 is my real part. Put a star there if you have a highlighter. Okay, and let's pick on Cheyenne. What are my imaginary parts? Good, 6i and 8i. But it's not going to be a positive 6i, it's going to be a negative 6i, right? When it distributes through. So negative 6i and a positive 8i. Okay. Kayla, when I add my 16 minus 13, what am I going to get? Good. Okay. And Cobian, when I add my negative 6i and my positive 8i, I'm going to get 2i. Good. Okay. Everybody good with that? So we introduced a new number called I, an imaginary number, part of the complex system. And now we have added and subtracted with them. Yes. Not necessarily. Good question. Yep, I didn't give any good examples of having a negative. Yes, if this had been reversed, if we had an 8i here and a 6i here, the 8i would have been negative and it would have been bigger. So it's entirely possible to have negative values for the imaginary. Very good question. All right, so we've added and subtracted. What's the next thing you think? Multiply and divide. Good prediction. All right, so we defined the square root of a -1 as I. Okay. That means that I squared is going to be the square root of -1 squared. What happens when we take the square root and square it? They cross out. They're inverses of each other, right? The square root of something squared is just going to make that all disappear. So I squared is going to be a -1. And every assignment that you do from here on out for this chapter, it's a good idea in the top of your notebook paper to write that down. Square root of -1 is I, and yep, I squared is a -1 until it becomes second nature and you don't have to think about it. Okay, so you want that for a reference. Mhm. Okay. All right, so first example, I'm going to multiply and write the answer in standard form. Remind me, what was standard form for a complex number? A plus bi, real part plus imaginary part, or real part minus imaginary part if the imaginary part was negative. Okay. All right, so here we go. What are we going to do when we have 6 times the quantity, 3 plus 4i. What do you think, Alexis? Good. 6 times 3 and 6 times 4i. So when I take my 6 times 3, I'm going to get what, Jordan? 18. Good. And when I take my 6 times 4i, I'm going to get what, Veronica? Very good. Okay. Easy enough, right? Works very similar to what we do with when we have variables in our parentheses. Okay. Letter B, same kind of idea here. But now we have an imaginary part being taken times a complex number. Okay. So, Joseph, what am I going to get when I take my 15i times a negative 1? Nope, just a plain old negative 1 times a positive 15i, negative 15i. Okay? But what happens, Tristan, when I take negative 15i times a positive 2i? Good, and it's a positive right now, isn't it? Okay, but we just defined i's to the second to be equal to what? Negative 1. So negative 1 times 30 is going to be a negative 30. So when we write this in standard form, we want our negative 30 to be first. That's our real part. Okay, then we write our imaginary part afterwards. There's our first negative imaginary part. My first example to have one. Okay. Yes, Dylan. Not Dylan. On 30, the I squared, it becomes a negative 1 because up here we said whenever you see an I squared, we want you to remember that I squared stands for negative 1. So anytime we see an I squared, we simply substitute a negative 1 in there. Because in standard form, the real part's always first and the imaginary part's always second. So we just change the order. Okay. And it's now real, isn't it? It doesn't have an I with it anymore. When we squared that I, it became a negative 1, and it brought it back to the real side. Okay. All right, letter C. Here we go. When you guys factor, a lot of times you use FOIL boxes, right? We can do the same thing here. You don't have to use a FOIL box. You can if you want. But we have a 4 minus 12i. That's being taken times an 11 plus 8i. Okay. What is 4 times 11? 44. What is 11 times a negative 12i? Calculators. This is why we want your calculators. Negative 132i. What is 4 times a positive 8i? 32i. Excellent. And what is positive 8i times a negative 12i? Good. Negative 96i squared. Okay. Almost there now. Here's my real part, right? Here are my imaginary parts. But won't this one become real as well? Because I squared is, and negative times negative is positive. So this is really a real number in disguise. It's good old 96. Okay. So 44 plus 96 and 32i minus 132i. Okay. We'll pick up where we left off yet tomorrow.